Good morning, good afternoon, or good evening. Wherever you are in the world, welcome and thank you for joining us. My name is Carl Anthony, and this is AutoVision News live at AutoSens at InCabin USA 2024. We are in the heart of the Motor City at the Huntington Place in downtown Detroit. Joining us is Rube Perez Aranda, CTO and co-founder of KDPOF. Rube has over 20 years experience as a manager of R&D projects for the development of digital communication systems, covering the full path from information theory-based research to integrated circuits qualification and series production. Rube is an IEEE senior member and an industrial engineer specializing in electronics and automation control. Rube, welcome. Thank you for being here.
Thank you. Nice to meet you again.
So Rube, allow me just as we begin to give a little bit of a backstory, because we did a previous interview that's on the AutoSens and InCabin YouTube channel. So a bit of a backstory here. Connecting sensors to AI units requires a data network deployed throughout the vehicle, where information generated by sensors is aggregated by zonal ECUs and then transmitted to the AI units. Now, aggregation amplifies the rate requirements between 10 and 50 gigabits per second per link. In our previous interview that I mentioned, Rube, for the AutoSens and InCabin YouTube channel, we analyzed that legacy electrical physical layers face limitations such as high insertion loss and return loss, which translates into signal integrity and EMC issues that ultimately impact the cost and energy efficiency. Now, these problems will worsen over time as cable and connectors age, making electrical solutions really inadequate for future scalability. In this scenario, optical links become a very attractive solution, offering superior EMC performance, low power consumption, and scalability for future data rates. That's a summary, Rube, of what we talked about in that prior interview.
Yeah, I think it's a very good summary. So, in KDPOF, we are a Spanish company, a fabless company that we were founded in 2010. We invent high-speed optical communications for automotive environment, specifically for automotive environment. We already have chips in series production for gigabit over plastic optical fiber, and now we are really focused in the development of the new multi-gigabit optical communications for automotive using a different fiber, that is glass multi-node fiber. And we offer to the market fully qualified automotive-grade chips that integrate photonics, electronics, and optics in a single chip solution.
Sure. What is KDPOF showing here at AutoSens for 2024, Rube?
We are presenting in this event the new optical transceiver for multi-gigabit. This is the KD7251. It's able to operate up to 10 gigabits per second. We are showcasing here in a booth, in the booth number 258, a demo of a symmetric transmission of 10 gigabits using automotive-grade optical fiber connectors and cable. So the people can touch the cable, can play with the connectors and see how flexible and robust is this cable without affecting the performance of the system.
Right. Rube, what are some of the other main features and characteristics of what you have on display here at AutoSens?
This chip is very special chip and unique chip. This chip is going to be certified functional safety ACB, qualified according to ACQ 102 grade 2, and we have different functionalities. We have in the chip the capability of operating as Ethernet 5, so supporting the connectivity between some ECUs and artificial intelligence units with symmetric traffic. But this chip also includes MIP interfaces, so CSI2 for connecting cameras, radar, LiDAR, or DSI2 for connecting displays. And we also support IEEE 1722 encapsulation, so we encapsulate over Ethernet the MIP and the remote control protocols. We have also the support of aggregation, disaggregation, drop traffic, because, for example, you can use this chip to aggregate the traffic from LiDAR, camera, radar, and put all together over a single fiber and send to the main processor in the car.
Right. Ruben, I think the next question, and I would imagine you get asked this frequently, is how do you integrate all of these functionalities into an optical transceiver? How is that possible?
Yeah, it's a very good question, because it's one of the most difficult things. Yeah. So I would like to emphasize, because it's a single chip solution. So we integrate the optical interface for connecting the fiber directly to the chip, the optical engine that make the optical coupling between the photonics and the fiber, the photonics, so laser, photodiode, and electronics, and everything in a hybrid package, supporting assembly process in a PCB. So this is the very best optical transceiver able to support reflow process for direct assembly in a PCB.
Right. You had mentioned that this is a single chip solution. Ruben, can you elaborate more on the characteristics of this single chip that we've been discussing?
Yes. So inside this chip, we have first a CMOS die. This CMOS die, the silicon integrates the DSP, the optoelectronics, the analog mixed signal circuits, the high-speed digital interface, microprocessors, monitor, etc. And we decided to integrate everything in a single die using CMOS, because CMOS tech nodes are qualified for automotive and allows you to produce in very low cost. So this is the first element that we have. This is then we have a VCSEL, that is the laser, and we have the photodiode. And these three dies are assembled over an organic substrate, that is a BGA substrate, and on top of that we have a lead. This is a small structure that implement the optical lenses to couple the photonics to the fiber, and the mechanical interface with the optical ferrules of the cable.
Yes.
And this package is very innovative, because it requires very high precision positioning of the photonics and the lead, and requires to select the materials and the glues, etc., to support the reflow process that is operating up to 345 degrees Celsius. So you need to select all these recipes for assembly of this chip and the materials very well.
Ruben, I imagine this question is something you might get asked frequently as well, but if you have this single solution approach and this hybrid packaging, which is remarkable and innovative all at the same time, but how do you manufacture it in a series production or in a method that supports high volume for the automotive industry?
Yeah, it's a very frequent question and very good question. This hybrid package is not a standard package. So you cannot subcontract these big companies doing assembly and test for you. You cannot contract the big OSATs in Asia. So what we are doing in the company is setting up an assembly facility to make this assembly. So we are setting up manufacturing lines, fully automatic manufacturing lines, including all the steps that you need. Wafer sort, wafer processing with dicing, high precision positioning, die bonding, flip chip, wire bonding, lead attached, final test, etc. So we subcontract the manufacturing of the CMOS die, we subcontract the VCSEL on the photodiode or the substrate and the lead, but we put all together inside this manufacturing line to guarantee a very high quality and low cost production of this very unique kind of product for automotive industry.
Absolutely. Ruben, from all of us here at from Sense Media as well, time sharing your expertise and taking us through your product portfolio and your demonstration here at the show. So thank you for that. Have a great rest of the event, and when everything wraps up, safe travels home. I've truly enjoyed this. Thank you, Ruben.
Thank you. It was a pleasure.
More to come from AutoSens and InCabin USA 2024 at the Huntington Place in downtown Detroit, alongside Ruben Perez Aranda. I'm Carl Anthony, AutoVision News.